All right, so next up we have Jodi Halpern, who's a professor of bioethics, and she's going to talk to us today about why we should be even thinking about teaching scientists and computer scientists about ethics. I'm going to leave that up so it doesn't do the same issue.
Do me a favor. I just want nothing on. I'm a philosopher and a psychoanalytic psychiatrist. So my favorite thing is just to talk to you guys and not to have a slide.
Ah, here we go.
I often have slides.
There you go.
I'm like, what Nico said. What Nico did. Okay. I think that the point of Lee's question was that I feel, in actually a lot of my work, I love to think about big picture. Like even in gene editing, we've been involved in work on germline gene editing and how it could change the world. And so you've heard a lot of big picture today of why we're doing Kavli and the scope of our problems. But what I thought would, because first of all, I'm so excited to see so many colleagues here, people from UCSF, thanks for coming over, so many of our grad students and postdocs. And I was thinking, because the heart of Kavli for me is that we provide an opportunity for grad students and postdocs in their science training or in the humanities and social science training to really learn to think about ethics early on and change the world by thinking upstream. And so I wanted to give kind of a very practical talk about how important it is that you think about ethics right now in your training. And this talk will really focus on just a little bit of research we did and some other findings about how much ethical reasoning is part of being a scientist and why right now. So basically, scientists, especially in the spokes that we're looking at, are increasingly involved, basic scientists are increasingly involved in the translation of their discoveries into products. And we've heard about that. That's why my title was Compression from Bench to Bedside. People have mentioned the compression. So some of you are ready. I mean, I see grad students and postdocs already being invited to partner with companies. This is happening in gene editing and in neuroscience. And what we see is that as scientists, junior scientists, and senior scientists become more and more involved in translation, they're playing brand new roles in engaging with individuals with diseases.
It's going to shut down. Keep going. The thing's going to shut down again.
Okay.
Just keep going.
But we
You
don't
can't
need it
close
'cause
it.
we're just doing
I know,
panels
but you
after.
can't close it. Just keep going.
Okay, but we just have panels after.
I understand.
Okay. All right. We're having some technical. Okay, I forgot what I was saying. Basically, I was talking about playing brand new roles in engaging with the public. So what we see is scientists now meeting people with diseases and speaking at disease foundations, speaking in the media, knowing they're addressing people with diseases. We see people increasingly involved, basic scientists in fundraising. And I would say that overall, in gene editing and in neuroscience, I have a little more to say about AI later, but I would say at least in gene editing and neuroscience, two of our spokes, we see basic scientists becoming, as they never have before, spokespersons for cures. And I find this fascinating. I'm thinking Brad probably doesn't know this because this is before you came here. Lee, I think, maybe has heard me say this. But all of this started for me in 2016 when the world was very different. The basic scientists in gene editing were not used to being spokespersons for cures. So a couple of the leading IGI scientists came and met with me because they were very concerned, because they were getting letters from people who were desperate with genetic diseases and their families. And with real humility, the IGI scientists said to me, look, we're trained in biophysics or chemistry. This is not our training. What do we say? How do we honestly communicate to people without, we want them to have hope, but we want to honestly communicate to them about the likelihood of cures. And that was the world in 2016. That has changed very quickly around the world for gene editing scientists and neuroscientists. So we did a research study in 2018 and 19 where we studied 45 gene editing scientists. 24 of them were basic scientists. I'm talking to you about them more because that's Kavli relevant. The other were clinician scientists. And of the basic gene editing scientists around the world, by 2019, the majority of them were directly reaching out to the public as part of their role. They had become involved in working with companies, and they were going to disease foundations to speak about cures, and they had become very involved in really the hope that was building in society about CRISPR. And what was really interesting, we did at least hour-long interviews with all 45 subjects, scientists. And what we found is that they, first of all, described this unprecedented historical move into translation of basic scientists, and said what's happened is there's such limited public funding that the only way, and they really believe in the promise of CRISPR, and the only way to develop our science and eventually lead to medical cures is to get involved very early on with industry. Not only is that the only funding that can really take us anywhere, and we were talking earlier, follow the money, that's where it is, but the NIH really didn't want to fund anybody who couldn't show that industry was interested in their product. So that was absolutely essential to get involved. And these scientists very much believed in the promise of CRISPR, and you've seen with Brad's slide how much promise has already been come true. So they felt very aware that this funding was pulling them into industry, and that the goals of industry were pulling them into roles as public spokespersons for cures. They were also, though, in their in-depth interviews with us, aware that this created some uncomfortable contradictions for them. As they were signing up, some of them were involved in first-in-human clinical trials, or at least going to disease groups to promote people thinking about becoming research subjects. They were aware that that kind of speaking towards cures and getting people's hopes up was essential to how they communicated for fundraising and for getting clinical trials off the ground. And they really saw that the reason that research subjects signed up for the first-in-human clinical trials was because they overwhelmingly believed that they would receive a cure from being in a very early research trial. But they themselves, the scientists, felt that the better reason to be in a trial that early was altruism, because we know that early phase trials don't necessarily lead to cures for the initial people in the trials. So the scientists were aware of this ambiguity and uncomfortable about it. I want to make a point here that the cause of people unrealistically believing that a phase 1 or early trial might give them a personal cure, the cause of that is not CRISPR. CRISPR has caused a lot of excitement for all of us because of how incredible some of these results have been, to use that language. But there's well-known research that I've been involved in. Our group did some of it. Others here have done some of it. For just traditional cancer research trials before CRISPR, et cetera, that 90 to 95% of people who go to the NIH to be in a phase 1 trial go there believing that they're likely to have a cure. And yet maybe, for those of you who don't know much about clinical trials, a phase 1 trial is a toxicity or dosage trial of a traditional medication. So those trials have maybe 1 to 2% chance of giving you any improvement in your cancer. And those people, those 95% who go to the NIH when they have a very serious cancer to be in a trial expecting or hoping for cure, not just hoping, but believing that they may get a cure, I don't know if you realize this, but a lot of those people are MD PhDs. So this is not the issue we have in healthcare of, which populations even understand what's going on in research, et cetera. This is an emotional, desperate conviction. It's a cognitive distortion that happens when people are very afraid and living with very serious disease. And there's a name for it. It's called therapeutic misestimation. And therapeutic and misestimation in that you way overestimate how likely, being a research subject, how likely it is that you'll receive a personal cure. And this is a very difficult problem in all clinical research. And it just became a problem in these highly innovative therapies as well. And we just saw that the scientists that we interviewed were very concerned about this. And they said, we would love to have more ethics education about how do we do it? How do we balance encouraging people to be in trials? Because the whole reason we're doing this is we believe we can get to cures with CRISPR. And we can't do that without clinical trials. but we also don't want to have research subjects coming into the trials with unrealistic expectations. They also, though, honestly told us, the scientists, that while they felt these ethical issues, this conflict of obligation to serve a great societal long-run goal of finding a cure for future populations, and the short-run goal of how they treated the people in the trials, conflict of obligation, I'll get to that. They also said that even though this is really something that we were never trained to think about, and the training that they had, and we did a little survey at Berget as well, the training that most of the scientists had was, as you heard earlier, in ethics was about avoiding fraud and reporting data, but they had no training in this human subject or population engagement kind of ethic. And they were very concerned about that, the scientists. But they also said, frankly, though, with the structure of my role and the expectations, I'd rather outsource that stuff. So I'd rather have somebody else who does the ethics. And I think a lot of it was that they felt very uncomfortable with those conflicts. The conflicts seemed almost intractable to them. Okay, so that's the gene editing example from our spokes, because it's the one I've done research in myself, our group. But there's really quickly, actually it's good because Jack presented some of this with neuroscience. He talked about deep brain stimulation for Parkinson's and intractable depression. Well, that research has shown very much the same thing. And Jack even mentioned this. For that, the scientists involved in that work, like Jack, why he got involved in ethics, they're facing their own discomfort and perplexity about the same sorts of ethical conflicts of obligation. And one example of that is that the studies for deep brain stimulation, where you have electrodes implanted, and the one for Parkinson's worked out and the FDA approved it. The one for intractable depression, at a population level, the harm-benefit ratio wasn't sufficient for the FDA to approve it. But what happened to the research subjects in those trials, again, people who signed up believing that they would get a personal benefit, even though they were told it was a clinical trial, et cetera, is that some of the people in those trials did actually have, even though overall people didn't benefit enough, some had major benefits. And if you've ever had depression, if you can imagine a lifelong of intractable depression, now you've got these deep brain stimulation function going on, and for the first time in your life, you're not, or one of the first times, you're not severely depressed. And it was working. But because it wasn't funded by the FDA, at the end of the trial, the tech support for their DBS was cut off. And there was no, so one of the ethics there of fairness and justice, one of the most important things there is, and this has to do with economics and access and all of that, is that when we have research subjects, not only do we hope that they understand why they're in a trial, but what are our post-trial obligations to them? So that's a very important example. And I'm not even going to do an AI example because you've heard a lot about AI today, but I'll just say something we all know about just from reading the newspapers, which is another area where we see AI engineers facing related conflicts of obligation, is we see AI engineers who want to develop the products they're developing because it could potentially serve some maximal social outcome. But even when they're developing, they can be aware of that the product could have certain bias, risk, or even be used for human rights kinds of misuses. But they also don't have early on the ethics training to balance those conflicts of obligation between, just not doing something or doing something that could do a lot of aggregate good in the long run, but that has a lot of dual use or other risks in the shorter run. So I've used this term 3 times for the 3 spokes, but I'm talking to you about the phrase I use is conflicts of obligation. And I want to say that we're all very familiar with conflicts of interest. Conflicts of interest are why you have to report if you start a company or you get a lot of income from a company. You report it at Berkeley or in other academic institutions. That's when you have personal gain, and we want to make sure that your personal gain is not leading you to make decisions that aren't best from an ethical standpoint. That's very familiar. It's not very it's not very intellectually challenging to figure it out, but it's still important to regulate. But conflicts of obligation are fundamentally intellectually challenging because what they're saying is you have 2 different sets of obligations. And just to talk about why that would happen all the time, which it does, a lot of people, some people are very aware, I'm looking at the philosophy department over here, but a lot of people aren't aware that there are two very distinct philosophical frameworks that affect the ethics of science and technology. One framework, which we've heard referred to, Stuart referred to these conflicts too, is utilitarianism, which is one brand of consequentialism, but it's the one where both, let's just call it utilitarianism, where it's measurable outcomes that you're trying to do. You're trying to come up with a measurable aggregate outcome, and it's an outcome like improving health or decreasing infant mortality that's actually not itself morally imbued. It's a measurable world, objective, physical sort of outcome. And that is what scientists, as experts, we know research shows, that's how scientists think of ethics. They think like utilitarians. That's the default mode. So when you hear scientists talk about how much good their discovery can do, how much we can do for everything, people, health, the environment, quality of life, they're thinking like utilitarians about this long-term outcome benefit, or it might not, because it could happen quick these days, but it's a mass measurable outcome. And that's very important, but it's only one of two really important ethical systems. The other one, and by the way, research just came out showing that these two systems use two different parts of the brain. The other system is about where human rights and justice and fairness and all those considerations come up. And that is the system of not just the outcome and a measurable good like that, but how do we treat each other along the way? How do we respect each other's rights? How do we make sure disadvantaged populations are included? That's all about how we treat each other along the way. And the name of that system is deontology, because until about the 19th century, people used to talk about that system in terms of duties. Ology, study of, deont is duties. And deontology, the study of duties, was sort of almost all of ethics until the 18th, 19th century. It was sort of Good Samaritan ethics. And it was the idea that we all have ethics based on our responsibilities and duties. So parents have duties to their children, teachers have duties to their students, governors have duties to their state. That was ethics. Then in the 18th, 19th century, Jeremy Bentham, John Stuart Mill, and others were looking at their societies in London and places that had terrible conditions. People were living in squalor and terrible conditions, poor health, and they felt that the chains of duty and these traditional ways of thinking about ethics were keeping the world from making progress. And they said, let's think like social engineers. What if we put ourselves above society and take a look and say, what's the outcome we really want to see? What's a more utopian or better human life? And how can we work towards those outcomes? And so they were the utilitarians. And what's interesting here is you can see that by definition, the utilitarians did not want to be chained by these duties. And it turns out that by around the 18th, 19th century, duties the language of duties was supplanted by the language of rights, which is what we are all familiar with, human rights, individual rights, because it turns out duties and rights are really the same thing. I mean, the philosophers are going to definitely want to tell me all the ways that I'm not exactly. There's lots more to say about this. But where there's a right, if you have, I'm very concerned this week about women's rights over their body and their health. That's only a right because other people have a duty to respect it. Or, in this case, the U.S. national government has a duty to protect that right. So duties and rights are part of the same thing. Utilitarianism was designed to not care about duties and rights. So that's where we're at right now. So that means that we have these two different ethical frameworks, and they use two different parts of the brain, and scientists in their training right now are default only using utilitarianism. So they can do a lot of things to produce an ultimate benefit that they see as a social engineer without thinking at all about the rights of the people they're interacting with. And so the reason I wanted us to do Kavli is I want scientists early in their training to learn to think in both frameworks at once. I've been teaching ethics to leaders for 23 years at Berkeley at the graduate level, and it's public health ethics, et cetera, these issues. And the best people in my class are often scientists. You don't have to be a philosopher to be able to use both these frameworks. but you have to have training it early on, because you actually have to be pushed to get out of your default framework and think in this other framework. And when you think of both, you're going to face all these conflicts of obligation because the framework can conflict. But you can also come up with solutions. They don't have to conflict. You can come up with solutions where they constrain each other, but you can come up with solutions that are not ideal, but that allow for respecting rights and producing benefit. And an example of that is our group at Bergen, and I'm about to end because I see Lee looking at her watch. The group that we started 5 years ago, Bergen, you heard what it's called, Berkeley Group for the Ethics and Regulation of Innovative Technologies. We've been meeting with scientists and philosophers and others, policy folks. We've been meeting for 5 years and creating an intellectual environment where people can think in both frameworks. And the most recent example, we did this series this year on climate change, and what we saw is that carbon credits that maximize aggregate carbon sequestration often disadvantage already disadvantaged communities, and there's environmental injustice. And so what we thought about was how can we take that as a constraint, but also still try to do the positive impact on the environment, and we all think together about it. And this is what I hope Kavli will help all our grad students and junior faculty and all of us in science and technology do together. So thank you.
Okay. So we've got some panels up next. So while I pull the panel chairs in, if there are questions, go ahead and step up to the mic.
Okay, thanks, Lee. Anybody? Oh, great.
Okay, this is the perfect height. So I'm a first-year PhD student in bioengineering and also a population geneticist. But again, I'm a very early stage scientist in my field. And the thing is that my field is facing an ethical dilemma where scientists still use race as a proxy for biological diversity, which is proven to be incorrect. However, senior scientists in the field are very opposed to figuring out another way to quantify diversity without relying on that ancient system. And whenever I talk to these scientists, like pitching ideas, they're extremely resistant to it because they say, oh yeah, it's a necessary evil, we have to go with it. So what is your advice for like early stage scientists who want to challenge these norms, who know other scientists who are like very well known in the field, who agree with them on the fact that this needs to be changed, but no one wants to do anything about it?
Well, obviously, there's so much resistance to change that's such a problem. My most cynical thing that I say is that the older folks, we all have to just die off so that the young folks can change the world. But I do think that the goal of places like Kavli or Bergen or whatever is that there's sort of power in numbers. And it doesn't have to be large numbers, but that it's very hard to be a single spokesperson in graduate school. And not be, there's so much power dynamics in grad school. So it's always better to have several people so you already have you've already done a lot of really smart stuff. Like you knew there were people these scientists respect who are spokesperson for getting rid of the proxy of race. And so you show them people you respect tell us to do this. But you can also get more and more grad students and folks that are involved in Kavli, et cetera, to speak about it. We've seen that. I'm involved in a joint medical program here at Berkeley, where literally our number one agenda item now is we're the only medical school in the country where our first goal is anti-racism, and that came from students changing us over time.
Thank you.
Yeah, you're welcome. I think we should probably go to the panel. Thank you, everybody.